Okay, so moving on from the product rule, next up we're going to look at the quotient rule. And how do we use the quotient rule to find derivatives? So what does a derivative tell us? Just a reminder, it is the instantaneous rate of change or the slope of the tangent line. So if this is your graph, which compares distance over time, what would the derivative at t equals 3 tell you? Well, if you look at t equals 3, we have this tangent line here. That slope is the speed, or the meters per second, that the object is at exactly that moment, when time is 3 seconds. All right, so let's look at the quotient rule. So the quotient rule says if you have a function h of x that is the division of two other functions f of x and g of x, then the derivative of the entire function h of x will be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. And we have a saying that we use to help us remember this. We say h prime of x will be, we say low times d high minus high times d low over low squared. So we say, and it's kind of catchy, low d high minus high d low over low squared. Low d high minus high d low over low squared, which means the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. And you'll hear me say this throughout the lesson, and I'd say it a lot if we were in school too. Low d high minus high d low over low squared. So looking here, high, low. So it says there's f of x, and it says find the derivative of f of x using the quotient rule. So if that's f of x, let's call it f prime of x. Low times the derivative of the numerator. Well, what's the derivative of 3x to the fourth minus 9? Use our power rule. 4 times 3 is 12. X to the subtract 1 third. 12x to the third. Good. Minus high d low, the derivative of the denominator, the low part, 4x squared plus 3, the constant goes away and you get 8x to the first, so just 8x over low squared. Well, low squared is just 4x squared plus 3 squared. And there you go, and that's enough. You don't have to multiply this out. You can see that would be nasty. If you had to multiply this, square this, simplify, that would be just too much. So that's fine. Low d high minus high d low over low squared. There you go. Let's try some practice. For each function, find f prime of x using the quotient rule. So here we go. F prime of x. Remember, low d high minus high d low over low squared. So here we go. Low, derivative of the top, 3x plus 9 is just 3, minus high times the derivative of the bottom. Well, be careful here. 2 minus x to the first, bring it down. The constant goes away. You get negative 1 x to the 0, which is just negative 1, over low squared. Sorry, I just lost my train of thought. Sorry about that. So, there you go. Now, the next part says, write the equation of the tangent line at x equals 1. And I kind of skipped this before. So, a couple of things. Write the equation of the tangent line. Now, what you need for the equation of a tangent line is we're going to use what's called point slope form. So you need the point, you need a point on the line and the slope of the line. Well, the slope of the line at x equals 1 we can find by just plugging 1 into this. So let's see, f prime of 1, Well, that gives us, we have to plug in 1, so we get 2 minus 1 times 3 minus 3 times 1 plus 9 times negative 1 over 2 minus 1 squared. Okay, and then we solve that. Let's see what we get. 2 minus 1 is 1. 1 times 3 is 3. And then 3 plus 9 is 12. Times negative 1 is negative 12. Minus negative 12 is plus 12 over 2 minus 1 is 1. 1 squared is 1. So it's 15 over 1, which is 15. So the slope when x is 1 is 15. Now, what is a point on the original function when x is 1? Well, to find that, so this will give us a slope right here. When we want the point, we can plug in 1 into the original equation. So if you plug in 1 and find f of 1, you get 3 times 1 plus 9 over 2 minus 1, which is 3 plus 9 is 12. 12 over 1. 12. So we know the point 1 comma 12 is on the graph. So we call this point slope. Point slope is in the following form. We take the point and we write the opposite signs. And we write y minus 12 equals, and then we put the slope, which is 15, parentheses, and then we put the x value, x opposite minus 1. And this is called point slope. And what's kind of interesting is if we take this now, let's take a look. And if we graph this, which we get, let's see, sorry, where's the original? 3x plus 9 divided by, divide the whole thing, by 2 minus x. There we go. And we want to know at 1, what happens if I graph this line? Y minus 12 equals 15, parentheses, x minus 1. And if we look, this is the tangent line at the exact moment when you get 1. And it might not look like it, but it is. And you can kind of see it. The blue line is the tangent line when x is 1. There it is. So the rest is a lot of repetition, except number 6, which we can look at, but I would like to maybe look at one more here. So number 3, f of x equals 4 rad x over x squared minus 2. Remember, with derivatives, it's easier to write this as 4x to the 1/2 over x squared minus 2. And now we can find the derivative. Let's see. All right, so low d high minus high d low over low squared. Low times the derivative of the numerator. 1/2 times 4 is 2. X to the negative 1/2. Subtract 1 from 1/2. There you go. Okay. Next. Minus high. I guess we could put x to the 1/2. D low. D low. Derivative of the bottom. What's the derivative of x squared minus 2? 2x to the first. Constant goes away. So it's just 2x over low squared. There you go. So there you go, that's the derivative. Now, if you want to rewrite this, and we can, in a nicer way, we can write x squared minus 2. And instead of 2x to the negative 1/2, let's write 2 over rad x. 2 over x to the positive 1/2, which is rad x, minus 4 rad x times 2x over x squared minus 2 squared. And you see, I just did a little cleanup. That's it. I didn't really change much, but I fixed this, and I wrote this back as a radical. So not really much different. You could leave it either way, but this is much nicer to work with, and you're going to see that in a second. Because in a second it says, what is the equation of the tangent line at x equals 1? So you need two things. You need a point and a slope. To find the point, you plug in 1 into f. So you get 4 rad 1 over 1 squared minus 2, which is 4 times 1 is 4, over 1 minus 2 is negative 1, which is negative 4. So the point 1, negative 4 is on the line. And then we need to find the slope at 1, so we need to find f prime of 1, so we need to plug in 1 into this derivative. And you'll see it's a lot easier like this. Let's see, we get 1 squared minus 2, 2 over rad 1, minus 4 rad 1, 2 times 1, over 1 squared minus 2 squared. What is that going to give me? Let's see. 1 minus 2 is negative 1. Negative 1 times 2 is negative 2. 4 times rad 1 is 1. 4 times 2 is 8. So negative 2 minus 8 over. This is 1 minus 2 is negative 1 squared is 1. So you get negative 10. So that means we have the point, we have a slope. Now we can write the equation of the tangent line in what we call point-slope form. So again, we need the slope, we need the point. It becomes y plus 4, opposite sign, equals slope, and then the opposite sign, x minus 1. There you go. Okay, I'll leave 4 for you guys. If you feel like you've got it and you don't want to do 4, you don't have to. It's okay. I mean, those two are enough work, I think. Okay. Number 5, find the equation of the tangent line to the given curve at x equals 0. Now, a couple things about this question here that's kind of tough. This question does not give you the steps to get there. You have to know, well, first I have to find the derivative, then I have to plug in 0 into the original and the derivative and write it in point slope. So this is a lot of work as well. If you want to work this out, I'm going to give you the final answer. It's y minus 8 equals 1 parentheses x minus 0, which is y minus 8 equals x, which then, I guess, you can even rewrite that, y equals x plus 8. That's your final answer after you do all the work. Okay, now, the last problem here is a little tricky. It says, let h of x equal g of x times f of x. So take a look. Here's a table. It tells you when you plug in certain x's what you get. When you plug in certain, and you find the derivative, what you get, g and g prime as well. So here, what they're saying is this. Let h of x be defined as g over f. So g is the numerator function, f is the denominator function. Right? So here it says find h prime of 2. So h prime of 2, well, let's first find h prime of x, which is low and high. So low, derivative of the, that's backwards, sorry, stupid. Low, high. So low times the derivative of the high minus high times the derivative of the low, prime, over the low squared. So that is, well, what's f of x when h is 2? It's 2. What's g prime of 2? G prime of 2, 0, minus, what's g of 2? Let's see. G of 2, negative 3. What's f prime of 2? F prime of 2, negative 2, over, what's f of 2 squared? F of 2 is 2 squared. So this comes out to, let's see, 2 times 0 is 0. Negative 3 times negative 2 is 6, so minus 6 over 4, which is negative 6 over 4, which is negative 3 over 2. Okay. Write the equation of the line tangent to the graph at x equals 3. So here what you would have to do is find h of 3, find h prime of 3, get the slope, and you're good to go. Now I'm going to not do that for time, so check it out, try the rest, and then try the homework as well the next day on Thursday. Remember, just fill in this lesson and submit this lesson for work on Wednesday, and if you do have any questions, please let me know.